1.1 angles. So we are starting trigonometry. We're going to start with right triangle trigonometry, and that leads us to sort of a definition of what trigonometry is. And it's the study of the relationships between sides and angles. So it is a little different than geometry. Relationship between the sides and angles in a triangle. And in geometry is much broader. So let's start with some definitions. An angle is acute if the angle is less than 90 degrees. So for example, an angle that looks like this would be an acute. An angle is right if the angle is 90 degrees. We usually show it this way. An angle is obtuse if the angle is larger than 90 degrees. So for example, an angle like that, and an angle straight if the angle is 180 degrees. Alright, a couple other definitions. Complementary would be two angles that add to 90. Right? So, for example, if I have this as my first angle, and it's 28 degrees, and then if I have a second angle, that would be maybe 62 degrees, then together they would make a 90. So those are complementary. Supplementary would be two angles that add to 180 degrees. So let's start again with our 28 degree angle. So let's say that's 28. So supplementary, you'd end up with a straight angle, right? So we have to go from here to here. And that would work if this one was 152 degrees. And then a conjugate would be, and we don't use this one a whole lot, but two angles that add to 360. And again, we'll start with our 28 degree angle here. And then the 360 angle will go all the way from here, make it go all the way around. And then that would make this equal to 332 degrees. Okay, a couple definitions. Some other stuff that you need to know would be a whole bunch of Greek letters and what the symbols are. We use these a lot. Just names from the more common ones. So we use alpha a lot, and we use beta a lot. And gamma. That would be gamma. And then this would be delta. We use those a lot. We use theta quite a lot. We don't use too much in here, but in pi, we actually know that more as a constant, right? Sigma is used a lot, maybe not so much in trig, but definitely in other parts of math as a summation symbol, sum for sigma, or sigma for sum. And then omega is used a bunch in the sciences as well. And then we have a whole bunch of other ones here. So, but you can look that up in the book. So now let's look at the next part here. So like I said, it's a little bit of a review. So Pythagorean Theorem, well hopefully you know it. What we're going to do actually here is prove it. So this is one way that you can prove Pythagorean Theorem. There are many ways you can do this. So let's draw a right triangle. And let's go from this angle, we'll go straight over here. And let's say that that's a straight, not straight, I mean perpendicular. It's not bad. Okay, let's mark some stuff here. So let's call this angle A, we'll call this one B, we'll call this one C. That intersection there is D, and I said that that was a 90-degree intersection. In triangles, if angle A is here, and then side A would be here, and side B would be here, and then side C would be over here, but we're going to label this time as C minus D, because we're going to call this little d. So if that's D, then since the overall length is C, then that would be C minus D. Alright, so what are we trying to prove again? We're trying to prove that A squared plus B squared equals C squared. Okay, so let's look at this little triangle over here. So D, B, and C. So let's draw it the same orientation. So we'll do the hypotenuse this way. So the hypotenuse would go from here to here. And the hypotenuse in here is A, right? So that's side A. And then we need to draw the line down in the base. So let's see. So this is over here. Okay, and C is here, B is here, and this is the right angle at D. If that's right, then this is right as well. And then what do we know? Well, we know that triangle ABC, which is the large triangle, is similar to triangle, and let's do it in the same order, so CBD. And since they're similar, then we know that the ratios of sides that are in the same spots should be the same. So C over A in the large triangle, C over A in the large, is A over D in this smaller triangle. And then let's cross multiply, and so we would get A squared is C times D. Alright, let's look at the next triangle. So we'll do it a little different color. So now I'm going to do this triangle over here, and again I put the right angle over here. So imagine that this point comes over here. So here is this larger triangle. Oh, I wanted that to be straight. Okay, so that's side CD, right? So we're C minus D. And then this was the right angle, and then this would be A. So C is going to be up here. And then what other side do we know? We know AC is little b, right? AC is little b. Okay. We also know that triangle ABC, the original, is similar to triangle ACD, right? ACD. And then again, ratios are the same. So C, which is the hypotenuse here, so C over B is equal to B over C minus D. I'm going to cross multiply here, so we get B squared is equal to C times C is C squared, and C times D is CD. And we just said that CD is A squared, so B squared is C squared minus A squared. Let's put A squared over on this side, so we would get A squared plus B squared is C squared. And that proves Pythagorean theorem. Okay, I forgot to include this in your notes, but we'll just do the second one here. So what we're trying to find out here is the missing angles. Now, what you need to be familiar with still, hopefully, is that we know that in triangles, the angles always add to 180 degrees, right? So if that's 53, then that's right, that's 90, then you should be able to find D by doing 180 minus 53 minus 90, okay? Alright, since you don't have this, we'll do what you have here. So find the missing angles for triangle ABC based on the information provided. We know that A is 15 and C is 40, so find B. So angle B, to find angle B, I would do 180 minus 15 plus 40. 15 plus 40 is 55, so 180 minus 55 should be 125, right? Okay, next one says A is equal to B and C is 70. So if A is equal to B, then let's just say that we take two A's and we should be able to find two A's, right? So 2A's would be equal to 180 minus 70, which is 110. That means that A, which is equal to B, is 110 divided by 2, which is 55 degrees. So both A and B must be 55. And triangle ABC is a right triangle with C the right angle, so that means that C is 90. So this one again is pretty much the same way. So angle B is then 180 minus 90 plus 12, that's 102, 180, so that leaves 78 degrees over here. Okay, last couple things. Unknown sides, so here's Pythagorean Theorem at work, so we know that e squared plus 1 squared is 2 squared, so e squared is equal to 2 squared is 4 and 1 squared is 1, so that means that e would be the square root of 3. And here if that's 1 and that's 1, then we know that 1 squared plus 1 squared is equal to z squared. 1 plus 1 is 2, so that means that z would be the square root of 2. And I think the last problem in terms of the examples, here is Pythagorean Theorem in a word problem, a little bit more. So we have a 90-degree angle here. We want to know the heights. We know that 8 squared plus h squared, that's supposed to be an h. That's awful. That looks like a b. Plus h squared is equal to 17 squared. So that's 64. Plus h squared is, that's 289. Subtract 64. So that's 225. That's Pythagorean triple. The square root of 225 is 15, and this is in feet. So the height is 15 feet. And that should be it. Thank you.